All right, so I just realized I didn't record the virtual lab / in-person lab that we just did. So I'm going to really quickly give you a summary of what we did during that time. So what we did is we looked at this Google Doc that I'm going to share with everyone through the Canvas email. If I could get to it. It's not this one. That's a video I'm about to make for physical science. Come on, little bar thing, go away. There we go. Okay. So what we did was we just talked about some of the components of the lab. So whose doorknob is the dirtiest, right, is our question. If you want to make it a little more scientific sounding, you could say, how does the location of the doorknob affect how much bacteria grows? Our variables, our independent variables, the location or the type of doorknob. Our dependent variable is going to be the percentage of stuff that grows, right? This is going to be a lot of different things. This could be yeast, mold, mildew, bacteria. It's going to be really hard for us to tell and distinguish between those, but we're going to try. So I also talked about background research. For this, I would actually really like you to do some research, and I'm going to put some possible links in here for that. But I want you to research about bacteria, about mold, about mildew, about cells, about petri dishes, just writing one paragraph, giving some insight into why we might do this experiment. In the lab report document, this is known as the objective, right? It's usually more than one sentence here, right? It says include a paragraph that describes the subjects. So that's what I'm in reference to here. This is more like a research part of the lab. We also talked about the hypothesis, right? So we talked about, these are the 7 doors that we swabbed. We swabbed the tech door, Dr. Gray's door, the entrance door, the science lab exit door, which is in the science lab, the bathroom door for the boys and the girls, and the room 1, the main lab, we swabbed the door there, right? So we had 7 petri dishes, and then one of them was just for fun. We just swabbed and touched random stuff, and it's probably going to grow a lot. So you're going to write your hypothesis based on which one of those doors you think is going to grow the most stuff, right? If you're doing this at home, you don't have to do that many doors. You can do 2, and you'll write a hypothesis in that case that actually just talks about your 2 locations. So then the way we're going to collect data is in our petri dish drawings. Basically, we're going to draw what we see. So this could be 2 bacterial colonies that I see growing. And then you're going to write how much percentage of the dish is covered. So I might say that's 15%. You might think it's 10%. It's an estimate, right? Is it 100% covered? Is it half covered? Is it 20% covered, etc.? I'm going to upload pictures next Tuesday that will be pictures of our petri dishes that we used. So this Google Doc is about to be emailed to everyone. And it's a little messy because it's kind of just like whiteboard note type style here. So this is for the virtual lab / in-person lab on Tuesday, October, what is today? 11th. Okay, so next Tuesday, October 18th will be when pictures are uploaded that you can either use or draw. So as far as what we did for the lab, right, I made these little petri dishes. I did upload videos on how to do that, although I didn't have sound in them, so it's just me silently doing it. So watching it is optional. But basically, I filled up little Tupperwares with about 1 inch of the agar found in Module 1. At the very bottom, there's the whose doorknob is the dirtiest directions, right? You can find there exactly how to make this agar and how to make your own petri dishes, right? If you don't care about it, fine. Just read about it and see how it was done. Then what we did was we took a cotton swab, the kind that you clean your ears with. We swabbed something, like if I swab my computer microphone or video camera thing, and then we actually very gently touched the very top of the agar in the petri dish and made kind of like a zigzag pattern. Right, you have to be very gentle because this is Jell-O-like, so you can actually break it if you push too hard. And I don't think you guys can see, maybe you can, but you can see some of the streaking patterns that are made from the swab. Then we're going to loosely put the cap on, and we're going to store in a warm place for a week. Next Tuesday, I will be back to take pictures, right? We also had a fun, it's rubbing off. I'm going to have to relabel these. We had a fun Petri dish here where we just touched it and swabbed a bunch of different stuff. So we'll see how that one turns out as well. So what you need to do by next Tuesday is write a hypothesis, right, based on the 7 doors that are in this Google Doc, and complete your background research, right? I'm going to include a couple links. That's what I was about to do right here. Some videos, some articles that you can read to get inspiration for your paragraph here about bacteria and other types of microorganisms that may grow. Otherwise, I'm just going to relabel these with tape because it looks like the Sharpie is going to rub off, which is pretty annoying. And that's what we did during this lab. I also mentioned there's a macromolecules video in Module 2 now, and there's an extra credit option at the end of that video. So if you're looking for extra credit, go ahead and open the macromolecules video, watch the video, and then at the end, there is a way for you to get extra credit. All right, we did have 18 people attend today, which is awesome. I would like us to get to 30 people attending. So next lab, that is our goal, to have 30 students attend. Otherwise, I'm going to end this little video here. So thank you for those of you who were able to attend in person and those who weren't. Hopefully this video helps you set up what you need to do before next Tuesday, which is write your hypothesis and do your background research.